Hello guys, welcome to your channel Learning Point. In this channel lecture today, we are going to study the application of formulas of differentiation. We have seen all the formulas of differentiation in our first video. So if you guys haven't still checked it out, I'm giving a link of that lecture in the description. First of all, I would suggest you that go through that entire lecture, learn all the formulas and their workings very carefully. There are different types of formulas and functions that I have very nicely given over there in that lecture. Go through that and then come back to this lecture so that you will be able to make out all the sums and the points very nicely and clearly. So let's start with our lecture for today. For application of our formulas, we'll see lots of sums and understand how to apply the different formulas in different kind of examples. Let's get started. Come on. The first, I'll start with a basic sum very obviously. Suppose if I have y is equal to x raised to 3 minus 5x raised to 7. Suppose if this kind of a question is given to you, the question will always be the same. Differentiate with respect to x. Okay, so let us understand. We have to say over here differentiate with respect to x. We have to write this always in all the sums whenever we want to find the derivative. So now derivative of y is dy by dx, x raised to 3 and x raised to 7. These both are representing your formula x raised to n, which is having the answer n into x raised to n minus 1. So if you observe your first term x cube, the value of n is 3. So when I want to write the answer, it will be 3 into x raised to 3 minus 1, which is 3x square, minus this 5 is a coefficient of x raised to 7. So we leave this 5 as it is. X raised to 7, once again n value is 7. So 7 into x raised to 7 minus 1, which is 7x raised to 6. So therefore we write our final answer dy by dx is equal to 3x square minus 35 x raised to 6. So that is your first answer. It's a very simple sum. One second. Let us see the second sum. If I have y is equal to x to the power 7 by 5 minus 2 into x raised to 3 by 4 plus e raised to x. So looking at the question is still differentiate with respect to x. So we have to write over here, as I told you, DIFF differentiating with respect to x. So derivative of y is dy by dx, which is equal to the first term x raised to 7 by 5 once again represents our same formula of x raised to n. So the answer is n into x raised to n minus 1. So I will get over here 7 by 5 x raised to 7 by 5 minus 1 minus 2 is the coefficient, so we will leave it as it is. X raised to 3 by 4, again the same formula, which is x raised to n into x raised to n minus 1. So that gives me 3 by 4 x raised to 3 by 4 minus 1. I am repeating the formula again and again and again. So you should be able to make it from this. The importance of this formula, guys. It's a very important formula, very widely used formula. So you should remember this formula by heart. N into x raised to n minus 1. And for the last term, which is e raised to x, you got it right. It's an exponential function, and derivative of e raised to x is just e raised to x itself. So I get over here e raised to x. Then, in order to simplify, we will write it as 7 by 5. When I take LCM, it becomes 2 by 5. I can cancel off these both elements. So this will become 3 by 2. X raised to 3 by 4 minus 1. That will give me minus 1 by 4 plus e raised to x. So, in order to make the power positive for the second term, I can write 7 upon 5 x raised to 2 by 5 minus 3 upon 2 into x raised to 1 by 4 plus e raised to x. This is the value of dy by dx. Okay, let us see the next example number 3. Y is equal to okay. So now in this sum, 5 into x raised to 3 by 5 plus x root x. What we do over here is, for the first term, it is directly in the form of a standard formula of x raised to n. But the second term, which is x root x, I have to first of all make some adjustments over here with the help of my laws of indices. Yes, we have to apply the laws of indices in this particular chapter. I have given the link of the laws of indices chapter in the description. So if you want, you can also learn all the laws of indices very nicely from that video. For now, I will give you the point which is applicable over here. I can write this as a raised to m into a raised to n is equal to a raised to m plus n. That is one rule. And the second rule that I have to apply, root of a can be written as a to the power half. These are the two rules that we have to apply in the second term over here. So let us see what we will do. This is 5 by 2 x raised to 3 by 5 plus x into x to the power half. So we have applied one rule of indices. Then I get 5 by 2 x raised to 3 by 5 plus x. If nothing is in the power, then the power is 1. So it becomes 1 plus 1 by 2, which is written as 3 by 2. So now this is in my standard formula. So I can apply my formulas for this particular step. Remember guys, whenever we want to apply the formulas in derivatives or differentiation, we have to first of all make sure that all the terms are there available in the standard formula. If at least one term is available which is not in the standard form, we have to convert it first, and then we will apply the rules or the formulas of derivatives to all the terms together. So once again I will say, differentiate with respect to x. So I get derivative of y as dy by dx. 5 by 2 is the coefficient, so leave this as it is. You got it right. X raised to 3 by 5 again represents my formula for x raised to n, and the answer is n into x raised to n minus 1. So the formula value of n over here is 3 by 5. So I get multiplied by 3 by 5 x raised to 3 by 5 minus 1 plus 3 by 2 x raised to 3 by 2 minus 1. So you can see that I can cancel off this 5 and 5 over here. So I get the value as 3 upon 2. 3 by 5 minus 1, we'll need an LCM to can simplify this, which will become minus 2 by 5 plus 3 by 2 x raised to 1 by 2. Finally, in order to simplify, I can take 3 by 2 common from both the terms. That is one thing that we will do. Second, the power is negative. So I'll use once again a law of indices, which is a raised to minus m is 1 upon a raised to m. So the power will become positive. So it will become 1 upon x to the power 2 by 5 plus x to the power 1 upon 2. That is your value of dy by dx. That completes your sum, guys. I hope you guys have understood this. It's a very simple sum, yet an important one for you to remember with this, that whenever I have to apply the formula for derivative, all the terms have to be there in the standard function first, then only you will be able to apply your formulas. Great. Let us see the next sum. I'll take one more example of a similar kind. Y is equal to cube root of x multiplied by x minus 1 the whole square. Once again, I have to first of all simplify this. So how should we simplify? Cube root of x can be written as x raised to 1 by 3, and x minus 1 the whole square can be written as a minus b the whole square. X square minus 2x plus 1 the whole square. So not the whole square, I'm sorry, we finished squaring this. Now we will multiply this inside the bracket. So x raised to 1 by 3 into x square minus 2x into x raised to 1 by 3 plus x raised to 1 by 3. Yes guys, once again we'll apply the law of indices, a raised to m into a raised to n. So the powers will get added. So I get x to the power 1 by 3 plus 2, 2 into x to the power 1 plus 1 by 3, and for the last term raised to 1 by 3. Finally, I will take the LCM in the powers. So x raised to 5 upon 3, 2 into x raised to 4 upon 3 plus x raised to 1 upon 3. Yes, now further simplification is not possible. So where we stop simplification, we can start with our differentiation. So now we will say differentiating with respect to x. So derivative of y comes as dy by dx. This will be 5 by 3 x raised to 5 by 3 minus 1 minus 2, that is the coefficient, 4 by 3 x raised to 4 by 3 minus 1 plus 1 by 3 x raised to 1 by 3 minus 1. Now this 5 by 3 will remain as it is. 5 by 3 minus 1 will give me 2 by 3. 4 into 2, that will give you 8 by 3 x raised to 4 by 3 minus 1, 1 by 3 plus 1 by 3 x raised to minus 2 by 3. Finally, what we will do is we will be taking out 1 by 3 common from all the terms. So inside the bracket I get 5 x raised to 2 by 3 minus 8 x raised to 1 by 3, and in order to make the power positive we will take reciprocal, so the power will become positive x raised to 2 by 3. That is your value of dy by dx. Yes guys, that was about application of our first kind of formulas, which was algebraic formulas. These are the types of questions that you will be seeing in your questions or in your exams. Now let us see 2-3 more sums which are based on exponential and the logarithmic kind of formulas along with algebraic sums. Number 5, y is equal to e raised to x minus 7 raised to x plus log x. If I am this kind of a question, once again I have to write over here differentiate with respect to x. So derivative of y, as you all know, dy by dx is equal to derivative of e raised to x is e raised to x itself, but when I want to find the derivative of 7 raised to x, it is in the form of a raised to x. Answer for a raised to x is a raised to x into log a. The value of a is 7 in this particular sum, so I will get 7 into x raised to log 7 plus log x. You all know derivative is 1 upon x, so I get just 1 upon x, and that completes your answer. The application of exponential and logarithmic formulas is very easy guys. You just have to buy at the formula, substitute the formula, and you are done with the answer. Come on, we'll take one more example for this. Example number 6. If I have 3 into e raised to x minus 7 log x plus 11 raised to x. Once again, I will say differentiating with respect to x. So derivative of y, as you all know, dy by dx. 3 is the coefficient, so it will remain there as it is. E raised to x, derivative is e raised to x. Again, that 7 is coefficient, so we cannot do anything. So I get derivative of log x as 1 upon x. So either I can write multiplied by 1 by x, or I can just write 7 upon x. Effectively both will be the same. Plus, and for the last term, which is a raised to x, again I can say the answer is 11 raised to x into log 11. Is that very easy guys? Yes. So those who think that derivatives was difficult, you guys can always share this particular lecture link with your friends so that everybody can learn from here, and they can also find that this is not a difficult part, not a difficult chapter. It is one of the easiest and a very scoring chapter guys. Thank you for watching guys.